integral of secant cube x dx. Okay, if we think secant x as u, then it becomes u cubed, but to get du we need the derivative of secant x, which is secant x tangent x. We can spare one secant x from here, but there is no tangent, and then the simple u substitution does not work. But we know secant, there is a relation, identity, trig identity about secant that involves tangent in fact. So 1 plus tangent is secant square. Okay, let's break secant cube into secant and secant square. Let's see, secant and secant cube is secant square. Okay, and now we can replace secant square by 1 plus tangent square, 1 plus tangent square. But okay, let me write in this way. This can be written as, I don't know whether it helps, but we can write 1 plus tangent square and secant x. And if we assume tangent as u, then derivative of tangent is secant square. We had to have secant square. It's not, secant square is not there. So even if we change secant square to 1 plus tangent square, the u substitution is not gonna work. Okay, so this is not good. Now since we have a product, we can use integration by parts. Let's see, if we think this is u and this part is dv, do we know the antiderivative of secant square? Yes, the derivative of tangent is secant square. That means antiderivative of secant square is tangent. So we can use integration by parts. So let u be secant and dv be secant square x dx. Then what is the formula, by the way? That was integral of u dv equals uv minus v du. Okay, so we need to find du. Du is derivative of secant, that's secant tangent. Find the antiderivative, v equals tangent. Then we always go uv minus v du. So this integral is in fact uv, so secant x tangent x minus integral of v du. V is tangent times secant tangent, so that's tangent is square and secant dx. Okay, now we need to work on this. So this part is good, secant x tangent x minus, in this integral if we say tangent as u, then derivative of tangent is secant square, but secant, we don't have secant square here, so the simple u substitution is not gonna work here. Okay, let me go one more time. If we, for this integral, if we think tangent x is u square, then derivative of tangent is secant square, but unfortunately we don't have secant square, so this u substitution does not work. The only thing we can do is tangent square. Let's write tangent square in terms of secant. Okay, this secant, let me write in the front. So secant x tangent square, we know 1 plus tangent square is secant square. So tangent square is, subtract 1 from both sides, tangent square is secant square minus 1. So second here, tangent square is secant square minus 1. Okay, then our integral, the original question, I, let me write I equals secant x tangent x minus times, so let's distribute integral of, when we multiply secant times secant square secant cube x, I want to separate into 2 dx. Oh, this is the original question, negative, and there is negative, positive, integral secant times 1 is secant x dx. So this is the exact question we began with, so negative I. Now let's move this to the left side. Then negative I, where is I minus I becomes plus I when we move to the left. So 2I, 2 copies of the integral is secant x tangent x plus integral of secant, that was done earlier, okay, in number 2 formula. Antiderivative of secant is natural log of absolute value of secant plus tangent, okay, plus c. Okay, there is a formula, you need to take this as formula. Antiderivative of secant is natural log of absolute value of secant plus tangent. Now to get the integral, the question, we need to divide by 2. Okay, so I means the integral of secant cube divided by 2. So 1/2 secant tangent plus 1/2 natural log of secant plus tangent plus c over 2, let's say c1 over 2, new constant, let's say c. That's final.